All right, next up, let's take a look at the hybridization, shape, and bond angles of carbon. So remember that all of these things are just determined by how many things are attached to the carbon. So we can have 4 things attached to our carbon. We can have 3 things. Or we can have 2 things. So remember, we have 1 s orbital and 3 p orbitals that are going to hybridize to form our new bonding orbitals. And so when we have 4 things, we're going to use all 4 of these orbitals. And so we'll have what's called sp3 hybridization. So sp3 hybridized. And the shape of this is going to be a tetrahedral. Not a square, a tetrahedral. So remember how you draw this? There's the 2 H's, and then you have this wedge, which means the hydrogen is coming out of the board, and then this dash, which means the hydrogen is going into the board. And remember, this bond angle here is 109.5 degrees in this tetrahedral structure. So here's just a pictorial representation of methane, CH4. You can see its tetrahedral structure, sp3 hybridization. And so these single bonds can rotate. And so if we were to draw something like this, think how many carbons there are here. There's 1, 2, 3, 4, 5 carbons here. And then think about this structure right here. They look like kind of different molecules, but if you count 1, 2, 3, 4, 5, they're actually the same. These bonds can rotate, and so these two are actually the same molecule, just rotated slightly different. So again, we can have rotation about single bonds. Next up, we have 3 things attached, so we're going to hybridize 3 orbitals, and so 1 of our s's and then 2 of our p's, so we're going to have sp2 hybridization. And so the shape of this, think back to Chem 101, this is going to be trigonal planar. And so this is flat, right? Hence the planar word. And so if you draw the structure of this, right, carbon doubly bound to maybe another carbon, and then we'll just draw some H's at the end. Remember, these bond angles right here are approximately 120 degrees. If we wanted to draw this in our skeletal structure, it would look just like an equal sign, right? These two drawings convey the same amount of information. So here's the little ball and stick model of that. Right, all 3 of these structures convey the exact same information. The skeletal structure is just the easiest and most convenient to draw. Think back to Chem 101. These double bonds cannot rotate. And so if you have a molecule that looks like this versus a molecule that looks like this, right, these two are not the same. These two are not the same. In this top structure, we have these carbons on opposite sides of the double bond. This is called trans. And on this bottom one, they're on the same side. This is called cis, right? And so these two are isomers of one another. One is the cis version and one is the trans version. I do expect you to know the difference between cis and trans isomers. And then finally, we just have 2 things. So we're only using 2 orbitals, so just sp hybridization. And so think back to Chem 101. This is a linear shape, linear. So there's the little ball and stick model of that. And these bonds also can't rotate, but there's no isomers because there's only one thing attached to each one side. And so if we draw the picture of that, here's the Lewis structure. And then the skeletal structure, it would just be 3 straight lines in a row. Remember, this bond angle right here is 180 degrees. And the bonds cannot rotate. So let's take a look at an example of this kind of stuff. And so if I were to draw you this structure, I would expect you to kind of understand this stuff, be able to identify the shape, hybridization, bond angles, number of hydrogens on any one of these carbons. And this is a big part of OCHEM, is looking at this structure and thinking about what the 3D image of this compound actually looks like. And so let's just pick some random carbons here. So think about this carbon right here. It's got 2 bonds here. But remember, carbon always has 4. So there's an H coming out of the board and then H going back into the board because this is an sp3 hybridized carbon. And all of these bond angles are 109.5 degrees. Think about these 2 carbons right here. There's a double bond. Remember, carbon always has 4 bonds. So there's actually an H here and an H coming right here that we don't explicitly draw. And so 3 things attached, that's sp2 hybridization. This is all these bond angles are 120 degrees. And since the hydrogens or the carbons are on opposite sides of one another, this is the trans isomer of this compound. Think about this carbon right here. It's shown with 4 bonds, so it can't form any more than 4 bonds. It's got 3 things attached to it, so that's sp2 hybridization. And again, these bond angles are 120 degrees. And then think about this component over here. What does this look like? So we're coming from this oxygen onto a carbon, which let me draw this a little bit better. Coming from this oxygen onto this carbon, which is attached to another carbon, which is triply bound to another carbon, and then a hydrogen on the end. Note how what's on the top is exactly what's on the bottom, but think about some other things, right? This carbon is going to have some hydrogens attached to it. These 2 carbons are not going to have anything attached to them. And so think about it. There's 1, 2, 3 carbons there. 1, 2, 3 carbons there. And so these 2 carbons are sp hybridized and they're 180 degrees. It must be drawn, this bond right here must be drawn coming out as a straight line because that's what it is. It's 180 degrees. So in order to kind of get good at organic chemistry, one of the main things you need to be able to do is you need to be able to look at a skeletal structure and picture what the 3D image in your head looks like. When you see a triple bond, think linear. When you see a double bond, think trigonal planar. And when you see all single bonds, think tetrahedral.